In this video, I'd like to talk about solving equations with variables. And anytime we have a variable in our equation, we call this an algebraic equation. So we're basically solving algebraic equations in this video. Now, I want to talk about just the very simple cases, as this is an introduction to the very beginning of solving equations. Equations could get very complicated. But in this video, I'm going to focus only on two types, the two most simplest types of algebraic equations, and that would be equations of the form x plus a is equal to b, where a and b are some numbers. X is going to be our variable. So, and we'll talk more about this word variable, but for the variables, it's basically a symbol that represents basically a question mark. You could use any symbol you want, but in the context of math in general, algebra in general, we usually use the letter x if we need one variable. The other type of equation is going to be involving multiplication. So a times x is equal to b. So for example, what each of these equations would look like would, let's say, x plus 3 is equal to 10. So there's an example of the first type, and 3 times x is equal to 15. Okay, so let's look at these two equations. Now, before we talk about solving them, let's talk about what they mean. Well, mathematics is a language. And like any language, there's rules, there's grammar, there's punctuation, there's symbols, and there's characters. And in the context of mathematics, these two equations, so let's say this is equation 1 that we're going to solve, and this one over here is equation 2, these are basically sentences in the language of mathematics. And I'm assuming all of us are more comfortable speaking English than we are speaking mathematics. So let's translate these from one language to another, from the language of mathematics to the language of English. So this variable x is representing some unknown number. So what this first equation is saying is some number plus 3 equals 10. So some unknown number, if you add 3 to it, you get 10. So, or and this is just one way of wording it, or you could word this other ways as well. You could say, let's say something plus 3 is 10. So there's another way that, and there's, just like you could say things many ways in English, you could say things many ways in any language. In this other one, this equation on the right, 3 times something is 15. Now, before we actually solve these equations, let's talk about the word solving. What does it mean to solve an equation? So, you see, this idea of solving an equation means finding the value for that variable that gives you a true statement. So we're basically looking for what, so let's say we have x plus 3 is equal to 10. So you could think about that x as like a input slot. You could input any number you want. So something plus 3 is equal to 10. Now to solve the equation, you have to figure out, well, what number do I put in that box so that we get a true statement? So we get 10 on the left-hand side and 10 on the right-hand side. And so if I were to say some number, when you add 3 to it, you get 10. Well, you might say, well, that's got to be 7, because 7 plus 3 is equal to 10. And then we get 10 on the left, and we have 10 on the right, and that is a true statement. Okay, so to solve an equation is to figure out what number the x has to be, or what number to replace the x with, so that you get the same number on both sides of the equation, or so that you get a true statement. Okay, so I think a really illuminating visual metaphor for equations is a scale. So I have these two images of a scale right here. And an equal sign means let's say in the context of this metaphor, means the scale is balanced. And so let's say we start off with, I don't know, 2 pounds on the left-hand side and 2 pounds on the right. Now that they don't have to look the same, so let's say there's 2 1-pound weights on the right. So even though the left-hand side and the right-hand side don't look exactly the same, they both weigh the same, so the scale is balanced. Now if we had a 2-pound weight on the left and we had 3 1-pound weights, well, now the scale is no longer balanced. So in the case on the right, now the right-hand side weighs more, so the scale is tipped to the right-hand side. So what we want is, we want this. Equal means balanced. And if you think about the scale visually, we could change, we could add more weight, or we could take weight away, but the only way that we can make changes and maintain the balance is if we do the same thing to both sides. So I could add 3-pound weight to the left and a 3-pound weight to the right. So I've changed both sides of this scale, but I've changed them in the exact same way, or by the same amount. So the scale is still imbalanced. They're still balanced. Now that is how we manipulate or solve algebraic equations. We make changes to the equation, but we make the same change to both sides of the equation. Okay, so let's look at that second equation that we had from above. And I'll rewrite it down here. And that's 3 times x is equal to 15. Well, 3 times what gives you 15? Well, you might say 3 times 5 equals 15, so x has to be 5. All right, that's great. But I'm not focused on solving this specific problem. I'm using this as an example that we could use to solve other problems and other more complicated problems. So what we basically have here is, let me actually draw another scale. I'll use this as a visual example, so it's, excuse my lack of artistic ability, but here we go. There's a nice looking scale. Now what we have here is, on one side of the scale we have a 3 times x, and on the other side of the scale we have a 15. And what we want to take this equation and convert it to something that looks like this. We want to know what is x. So x equals some number. That's what we're looking for. And so what we want to do is isolate, or get the x by itself. So right now we have a statement that says 3x equals something. What we want is x equals something. So we want to get rid of the 3. And when we have a 3 next to an x, that's multiplication. Now in algebra we generally don't use a symbol when we have a number times the variable. Let me just scroll down. I'll scroll right back up. But for addition, we use a plus sign, 3 plus x. For subtraction, we use a minus sign, 3 minus x. For division, we could say 3 divided by x or 3 over x, either one. But for multiplication, we would just say 3x. And what that means is 3 times x. The reason we do this is because we use x for a variable, but also x is the symbol for multiplication. So we don't want to use the same letter in two different ways. Okay, so when you see a number next to a variable, you have, that means multiplication. Okay, so let's go back up to this problem. We want to get rid of this 3. We want just the x on the left-hand side of the scale, or the left-hand side of the equation. Now, you're not going to draw a scale every time you solve an equation. I'm just using this as a visual aid in terms of how to solve equations. Well, we're allowed to make whatever changes we want to the left-hand side as long as we make the exact same change on the right-hand side. And by change, we can add something to both sides. We could subtract something from both sides. We could multiply both sides by a number, or we could divide both sides by a number. What we're going to do here is divide, because the opposite of multiplying by 3 is dividing by 3. And so I'll say take the left-hand side and divide by 3. Because if you take a number and you multiply it by 3 and then you divide it by 3, the times 3, the divide by 3, it's equal and opposite, so they cancel each other out. Just like adding 5 and then subtracting 5, again, those would cancel each other out. But whatever we do to one side, we have to do to the other side. So then on the left-hand side, the times 3 and the divide by 3, they cancel. So the left-hand side simplifies to just x. And on the right, since we're doing the same thing, dividing by 3, 15 divided by 3 equals 5. And so that would be our answer. Once we get x by itself, once we isolate x, that's our solution to the equation. 3 times 5 on the left will give you 15, and you have a 15 on the right. It's a little beyond the scope of this class to look at more complicated equations, but this is a good introduction to just the general idea of solving equations. To solve is to find the value of x. That gives you this. That gives you balance. 3 times 5 on one side, 15 on the other side, they mean the same thing. And the way in which we solve the equations is by applying mathematical operations, adding, subtracting, multiplying, and dividing, but doing it in the same way to both sides of the equations. If you're going to change one side, you have to change the other side in exactly the same way. All right, and that about does it for this first introduction video to solving equations. And the next thing we're going to do in my next video is look at how this idea and this process relates to application problems or word problems. All right, that does it for this video. I hope this was helpful.